Thank you so much for joining us. People who are joining us on our social channels, I request you to join us using the Zoom link that is there in this chat. Right. So let me share the link to the Zoom as well. Great. Yes. Hi, Prasad. Thank you, Shubham. Thanks, Sham. Thank you, Shubham. People who are watching us on YouTube and Zoom, I request you to mute one. Right. Amazing. Okay. So you're live. Amazing. Thank you so much for joining us. And today we would be seeing how to know a little more. We'll know a little more about encryption and hashing. So I request everyone who has joined us for day one, to continue learning, and people who are joining us for the first time, these 5-day challenge learn blockchain is part of our blockchain bronze program from Pixeltest. This particular 5-day session is absolutely free, and yeah, the certification would also be provided for this. Only thing that we would require is consistently and sincerely be here, join and learn along. Okay, thank you so much for joining us. People who are joining us on YouTube, I request you to join us using the link for the Zoom session on the chat. Right? Okay. So we'll be beginning. So our sessions begin with this technique that we use called the Ho'oponopono technique. This Ho'oponopono technique, for the people who are joining us for the day two, would already be aware, is a Hawaiian technique which helps us clear negativity and self-doubt. I request everybody to close their eyes, put their hand on their heart, and repeat these statements after me. Okay. And this technique involves use of these 4 high energy, high vibration statements. I'm sorry. Please forgive me. Thank you. I love you. We are going to say the same statements to our own self. Right? I'll be taking my name during these statements. You'd be taking yours. Okay. I'd be saying Sachi. You'd be saying your own name. Say Rahul. Okay. So let's begin. I request you to be in a quiet environment. You can focus on your breath. Relax your breath. Relax your forehead. Relax your eyes. Relax your cheeks. Relax your shoulders. Relax your feet. I'm really sorry, dear Sachi, for not taking care of you. I'm so sorry, dear Sachi. Here you'd be taking your name. I'm so sorry, dear Sachi, for disconnecting with you. I'm so sorry for leaving you alone. I am the one who judges you so much. I am the one who criticizes you so much. Please forgive me, dear Sachi, for underestimating you. Please forgive me for not believing in you. Thank you, dear Sachi, for letting me having this beautiful experience of life. Thank you so much. From now on, it doesn't matter who doesn't love you. It doesn't matter who doesn't appreciate you. Because I promise from now on, I love you. I am here and I would never let you go. Take a deep breath, rub your hands together, and put that energy to your face. Amazing. Just give one word in the chat box. What was the experience? What was the result of this Ho'oponopono technique before and after? The people from all social channels, Prashant says, excellent, relaxing, calm. Vijay says, peaceful. Pradeep from Zoom says, good. Thank you so much. Thanks, everyone. So we would be proceeding forward towards the session. Okay, great. Let me share my screen. So we are on the day 2. Today we will be covering a little more in detail about the fundamentals of blockchain. Great. People who are joining us on Zoom, you can type in which city you are from and your current background, what you're doing currently. Yes, brother, you can go ahead and let us know which city you are from. Okay. Yeah. Thank you so much. Yeah, people from Bangalore, people from Hyderabad, Trichy. That's great. Pradeep says he's from Kanpur, doing an IT job. That's great. It's really nice to have you here, Pradeep. Right. So yesterday we have learned on blockchain the evolution of currency, the trigger, the 2008 financial crisis, and we also learned how it triggered the evolution of the cryptocurrency, then Bitcoin, and how it gives blockchain the properties of the security and immutability and transparency. Right. So we are going to continue further on encryption and hashing. So how does that work is basically encryption is the oldest use for cryptography. Even if in old kingdoms also, when somebody has to send a message from their kingdom to other kingdom, they used to encrypt it and maybe add one character, one length, or make it in a different intonation and give it to the messenger. The messenger would not understand how to decrypt it. Only the other king or the person, the people team there or their ministry, one person would decrypt that and read the message to the king, right? So person A wants to send a message to B. Let's say the message is M, and let's just say there's other person who F who need not know what is there, right? So a person who is there, who is eavesdropping or trying to listen what is the communication happening, how do we override him? How do we send the message without intermediaries being known? Is called the encryption. And what is public key encryption? We'll understand that there is something called private key encryption and public key encryption. Private key encryption means if there is one secret key, for example, there is one word which if you add to all the words, you'll be able to decrypt it. So the private key encryption means it is going to the secret, whatever is there, it is used in encrypting the message and decrypting the message. But public key encryption means there are two keys, like how you have in banks, right? When you have both, then you'll be able to get it. Similarly, there are two keys. How they work is, well, while encrypting a message, the person put something called the public key, right? While decrypting the message, the person who is receiving it will use the secret. There are two keys. So there is one public key and then there is a secret, right? So B tells world whatever public a message is there, they'll be telling, but he will not share the secret. If A wants to communicate with B, she will be able to send a message. The only way to decrypt that message requires the knowledge of the secret, right? So there are two parts. One is the public message, and then there is a secret, right? So that is what public key encryption means. Okay. Now we'll understand a little about hash function. Basically, what happens in hashing is whenever you give a specific set of input, and that input is transformed in a way that you will not be able to reverse it, right? So it is in a one way, it is converted and encrypted in a way that it cannot be reversed. So that is why we use hash functions. There are many hash functions, and we will be using one specific hash function which is called SHA-256, SHA-256. What is a hash function? A function which accepts an input and returns a fixed length summary value, right? So how does SHA-256 work? I'll be sharing this link for you to understand it in a better sense. Okay, so I have shared it on chat here for people on Zoom. Let me share it with our friends on our social channels, right? So once you open this particular link, you'll be able to see that it is asking for an input and there will be an output, right? So let's just say if you give any small input, let's just say I'm going to give one dot, also it is going to get converted into a a 64 character or 256 bit fixed length complex list of a collection of characters. So this is very dynamic. Even if I add one letter also to whatever is the default input you are giving, let's just say I'm going to add B, you can see that the hash drastically changes. It is not just one or two characters that change. With every change, with every small change, there is a very big change, right? So that is what the hash functions do, and specifically SHA-256 is used in many online applications, many ways where you use it to encrypt passwords and messages, and a lot of encryption can be done. And this particular SHA-256 hash function is being used by Bitcoin on the blockchain network, right? So this is a little about SHA-256. And if at all, for example, you want to see the encrypted value of hash of AA, you will have something. So these could be some questions people can ask you. What is the hash of so and so particular character or string, right? So now you can see, even if I'm changing one A to just say this less than A symbol, the hash changes, right? So how many of you understood what is a hash function? Type H in the chat box. right? So I'm just going to summarize. If you make any small change in the input, there will be a dynamic change in the output, right? So that is what the hash functions do. Okay. So thank you, Madan, for joining us. And how how many of you have understood this particular hashing function? I'm sharing the link once again for the members who have joined us now. You can see this particular link shared on chat. If you give any input, let's just say I'm going to give any input USA, it is going to give you a fixed length complex string, right? So this encryption function, the hashing function, is used in a lot of applications, and even our Bitcoin blockchain network also uses SHA-256 for encryption, right? So if you understood this clearly, type U in the chat box. Thank you, Prashant. Thank you, Sushmita. Thanks, Aksham. Thanks, Priyanka. That's good. Okay, so let's begin. Now that we have understood what is a hash function, let's also understand what all are the possibilities that we could do with these. Okay, great. Till now, we'll try to understand a few blockchain applications, right? So hashing functions, will cover a little about it as we progress, but we'll also try to understand what are blockchain applications, right? So one good thing about hash functions is the hash functions secure each transaction, right? So whenever there is an input in that, it is encrypted, and that encrypted message is not reversible, right? So given the output, you'll never be able to find a hash, right? The input that was given to the hash, right? So that makes every transaction super secure, and because every transaction is secure, the whole blockchain has the property of that hyper security, right? So we'll try to understand a few blockchain applications here. Applications as in how blockchain apps work, right? So now if you look at any traditional application, there is a platform like Google, Facebook, or Twitter, and they are interacting with their own database. And how do they interact? With their APIs, right? For example, if there is IRCTC or any other vendor, if they have to know if this particular PNR is confirmed or not, there will be a message, a function that will be written, will be used in the APIs. When there will be a function call, let's just say we enter submit on entering the PNR number, the API will fetch the data from the database and give it to the platform. This is how traditional platforms, traditional applications used to work. You can use that central platform like Twitter. Use, for example, if you're searching someone on Facebook, use their search API, and I mean you search on the platform. Search API is called the function, and that function is going to pick from the database and give it back. So initially there will be a front end, and then there will be a a call, and then there'll be data that is taken out and given out to the user. Now what happens in blockchains is a little similar process only, but only difference here we have is there is no central authority. The only authority here is user, and if a user wants to change the password, Screen is visible now. Okay. So now what he does, he calls an API, the user calls an API, and that invokes a smart contract. So now what is a smart contract? It is like a function only, a set of rules that will automate some manual process on the blockchain. Like we'll take an example of, let's just say, there's a supply chain use case, and if you want to automate these particular steps, if somebody makes the payment, then deliver the good to them, right? So that is what, if you want to bill, every time if somebody makes a payment, you cannot manually go and update that this person has made the payment, or now the delivery has to be done, now transfer the amount, now transfer the credits or coins. So you cannot manually keep doing it. So that is where we have something called smart contracts. The smart contracts are an agreement between user and user. For example, if I receive the good from you, then I will pay you. If let's just say that, then the automation script in that smart contract, what it will do, once it receives it knows that the amount is received, then only it will give access to the coins or something, right? So you can use this logic smart contract to write any kind of logic. For example, if a person meets the criteria to avail the insurance, then only give the insurance to him, right? So the eligibility check is happening, so that manual process could also be automated. But what difference that happens in traditional applications and the blockchain applications is, in traditional applications, these are all free applications because you need not have to pay to them, because they were using our data and showing ads to us and collecting the revenue from the advertiser. So they're not charging the user because they are charging the advertiser. But here, because there is no such system, there is a small transaction fee that is charged to the user, and that particular fee is called gas. So there are a lot of ways this gas is helpful. One is, this is a very nominal amount, and this helps you do your process faster. Second thing is, these smart contracts, also the whatever gas fee is there, these are also very quick and also automate a lot of manual stuff, right? And whatever automation is there, after that, whatever action steps need to be performed, that will be performed on the network, and the user is updated, right? Whatever details are there, it's updated. So how the gas fees is collected, whatever wallet that the user is connecting, let's just say is connecting MetaMask, BitPay or any wallet like that, from that wallet the gas fee gets auto deducted, right? So there is an application where the interaction is happening, and there is automation that is happening in the smart contracts, and there is updation happening on the network side, right? So this is blockchain applications. So how the technology stack works is, in the front end, you can have any of your HTML, CSS or JavaScript, right? So the look and feel of the website can be in HTML, CSS and JavaScript. But what happens after one person clicks on the submit button, that logic could completely be written on Solidity. This is the language that we use to write code on Ethereum blockchain, right? So the Solidity is the language that sits in the backend, and the whatever code is written is verified and processed in the backend. The language is called Solidity, and the front end could be any of the current standard technologies, right? So if at all you are becoming a blockchain developer, there are two options. You can still do your own front end, or you can still just do the back end, and the front end is done by the other front end developers, right? So I hope this is clear. If you have understood what is the technology stack for blockchain, type T in the chat box. Great. Thank you, Prashant. Thank you, Vivek. Thank you, Nitin. Okay, great. Now that you understood what is the tech stack, if anyone has any queries, you can unmute and ask or ask us in the chat. Great. No queries. Great then. So now what are the advantages? Now, one major advantage is because you are the person making the agreement between with the other person, there is no intermediate person that is required. So there is full autonomy to you and trust. Whatever documents are encrypted are on a shared ledger. Shared ledger, as in we have discussed in our first session. This shared ledger means the what list of transactions, the ledger is shared between multiple nodes. So when a ledger is shared between multiple nodes, the trust is the highest because you know that the documents are encrypted and you'll be able to access the the proper the legitness of that particular document because nobody can edit anything on that shared ledger. So there is high trust. Accuracy. Now, smart contracts are not just cheap and fast, they also avoid a lot of manual errors that come up because of tedious work, right? So, all that tedious manual work is now avoided because you can automate a lot of steps and rules in any particular program, right? So that is one more advantage. So now that we have understood a little of the advantages of the Solidity language or digital signatures and encryption in general, so we can go forward and understand a little bit deeper on what are blockchain wallets, right? So how many of you understood till now? Type you in the chat box. Thank you, Prasad. Thank you, Prashant. Thanks, Sushmita. That's great. Okay. So now what are blockchain wallets? So whenever you want to do a transaction or write your own Solidity code, what happens is when you run a Solidity code, a little gas fee gets debited from your wallet, right? And this wallet could be single wallet across any platform. If you're purchasing NFT, the same wallet. If you're purchasing crypto tokens, same wallet. A wallet is nothing but a transaction ID. It is very much like your digital wallets like Paytm and other wallets where you can hold, where you can receive and send money. That's all possible. And also you can what all things you can do is have your wallet connected to the services that you are using so that it can auto debit, right? So you can give permission and then it gets auto debited, right? So Bitcoin wallet, you do not have to remember like a password for, I just say Paytm or MobiQuick or PhonePe. You do not have to remember different passwords because all of the transaction happening on any platform can be connected directly to your single wallet, right? So you don't have to maintain a lot of different wallets or handle a lot of transactions also, right? So it always allows instant transactions whenever there is an exchange kind of a transaction or purchase kind of a transaction. All these transactions happen very instantly. So these are a few properties of blockchain wallets. If at all you want to download and create your own wallet also, we'll also be covering that. You can go ahead and download MetaMask, and the steps are relatively simple so that you can go ahead and create your own first blockchain wallet. If you understood about blockchain wallet, you can type BW in the chat box. Thank you, Prashant. Thank you, Sushmita. Thank you. Thank you, Rachana. That's great. Thank you, Pradeep. Now that we've understood the blockchain wallets, let's understand a little bit more about smart contracts. So as we have told, smart contracts is a set of rules. If you look at it technically, smart contract is a computerized protocol, meaning it will be working on its own, and wherein you write a standard contract rule that is immutable. Mutable means editable, immutable means you'll not be able to edit it. So even a single contract which could automate a lot of tasks, if there's any correction in that, you would not be able to do it, because you will be only able to write a contract rule. You will not be able to change it. If you change it, the network will know that there is a change that has happened, and it could also be rejected. So now you can understand that the smallest uh, particular element of a transaction is the transaction data that could be completely converted into a hash that we have understood. Now what we have understood is whatever smart contract that is being generated, uh, that could have a immutable nature. So the smallest node or the smallest blockchain element has its own encryption. He is encrypted, and the automation running over any of these sets of blocks or data is also immutable. So node is immutable, the point is immutable, and also the operation, the automation that happens around these particular points, these smart contracts are also immutable, which gives the immutable property to whole of the blockchain, right? So to summarize, how does a smart contract work? For example, a smart contract is nothing but an agreement between two people. Because of that particular agreement between two people, uh, what happens? The initiation of the smart contract happens. Then the smart contract will check if all the conditions are met for a successful transaction. If all the set of conditions are successfully verified or adjusted, then we go to the code business logic. So basically, the core business logic we could understand with an example of insurance. Let's just say you are, using the blockchain technology to, help insurance company, and make their Web2 presence into a Web3 presence. So what would their logic be like? For example, so and so person comes, only give insurance if his claim is 100% guaranteed. So how can you do that? So that is what we do in the core business logic, right? So after, every business will have its own. If it's a pharma industry, the logic will be different. If it is, travel, the limits and logic would be different, right? So after the business logic, there comes the encryption and blockchain technology. Here, what happens is, the hashing functions, the SHA-256, whatever we have discussed, they come into action and start encrypting each block of that particular blockchain. So after everything is encrypted and ready, then it goes for execution and processing. And here the gas fee is charged because it is taking some resources. It is using some RAM and system. That is the reason, the gas gets collected, right? And after this transaction is successful, the network is updated telling that so and so transaction has happened. So this is the case where, uh, you are successfully completing a smart contract transaction. Okay, so how many of you understood what is a smart contract? Type me in the chat box. A smart contract is nothing but a set of rules that will help in execution of a set of lines of code based upon the success or failure of that eligibility criteria. Okay, thank you, Prasad. Thank you, Sushmita. So that brings us to the conclusion of this particular session. In this session, we have learned a little about what hashing functions are used in the blockchain ecosystem, and we also understood what are blockchain applications and how the technology stack is divided, and a few advantages that blockchain has in general, the encryption property and the security property that kept on included in these particular systems, right? So in blockchain wallets, what we have discussed is there will be one wallet. You do not have to remember multiple IDs and passwords, but one ID and password you have to strongly remember. And this would help limit a lot of counterfeit or fake use of the wallet, right? So this will verify the ownership of the funds based upon the owners or the person who's holding the transaction, right? So you also understood that. You also understood the advantages that the blockchain network brings in favor. So thank you so much, everyone, for joining us and letting us know your views and experience. So if anybody has any queries, you can ask here in the chat box. Yes, we are here to help. If you understood today's session clearly, type U in the chat box. Thanks, Sushmita. Thanks, Rachna. Thanks, Vijay. Thank you so much, Pradeep. So it was really nice interacting with you on day 2 also. Keep coming every day until we reach the day 5. On day 5, we'd be doing our graduation day where certificates would be given, and also we would be explaining a little bit more about our deeper course, which is the blockchain bronze. And this blockchain bronze particular program has more insights and more details directly taught by Professor Pandurangan, who has taught at IIT Madras and is a leading faculty and member of IISc Bangalore. Right, he has done his PhD in 1984. So these particular sessions are part of all of his sessions as well. So I request you to also consider if you are looking at serious blockchain development, I request you to go ahead, consider it, and join our sessions as we progress. Okay, thank you so much, everyone, for joining in and making it more and more interactive. Thank you so much.